Good morning. Just to answer a question that I've been asked a lot of times these past 3 days. No, I'm not Pancho Villa. I just have a mustache because it's the Battle of Mustaches in Sweden this month, so I'm trying to win it. So that's the explanation. Before I start to present myself, so you know who am I got a request from the people at the door if you can move a bit into the center so that we can get some more people into the room. It looks like this is a very popular session, so I hope that you will not be disappointed. So, my name is Tiberiu Kovac. I'm also called TB. It's easier for anyone to pronounce it than Tiberiu. Or if you think about James Tiberius Kirk, then you might be home. You know, it might be easy for you to know how to pronounce Tiberiu. I'm a software engineer with over 20 years of experience. And since 2004, I started to train .NET classes, mainly in Sweden, or 90% of the time in Sweden, and the rest of the time I'm going and speak at different conferences. I do some research at the Royal Institute of Technology in Sweden, mainly on the multi-core era and the new multi-core paradigm that we are actually witnessing right now. I'm an INETA speaker and country lead for Sweden. I'm a Telerik MVP and Insider, and I'm Tibor19 on Twitter, and if you use the hashtag MSTechEd, we'll show up on the main MSTechEd site. So, the reason we are here is to talk about asynchronous programming in ASP.NET applications. And couple of years actually, last year, I started to have some problems with an ASP.NET application, and I was thinking about how can I improve the performance. And then I was looking, you know, I was Googling it with Bing, trying to find exactly where, you know, how can you solve these kind of problems before you get and do all other stuff. And the first thing that struck me was that there is not much information available. You can't see that kind of stuff available. So I started to do some research. And I found actually 2 articles. One from 2003 that deals a lot with threads, but the threads are not the way to go when you deal with ASP.NET applications. And the other one was actually from 2005, talking about some of the new features available in ASP.NET 2.0. Strange enough, every single time when I delivered that session, I got like 2 to 5 people in the room showing the hand that they know about those features in the ASP.NET. So for me, it feels like this could be a very educational talk for all of us here. If you have any questions, if you want to interrupt me, I think there are some mics at the side. Would be helpful if you ask a question on the microphone, or I would repeat it from here. So the agenda for today, it's quite simple. Hopefully we'll get the time to do all of those stuff, even if there are only 5 points. There is a lot of information that we will cover. So I will show the ASP.NET page lifecycle. Not that you don't know it, but repetition always helps. I will show you how can you load test your application just to show what kind of problems you might have without even being aware of. I will show how to start working with asynchronous pages. I will go into an MVC application and show how you can make an asynchronous page or asynchronous action in your MVC application. And then we will look on the next version of C# or the new async await features that were introduced in C# and how can they be used in an ASP.NET application, both in ASP.NET web forms and in an MVC application. Does it sound like an interesting agenda for today? Okay, then you are in the right room. So the page cycle of the life cycle of a page is quite simple. You have the init, and the init actually has a pre-init, then it has an init, and then it has an init completed. And init does a recursive call on all the controls and call their init method, and so on and so on. After that, you have load. When the data will be loaded, you normally do data binding, or you read data from the database, or do some calculations, or whatever your application needs to do. Then you have pre-render. Pre-render, it means, you know what, I am about to be done with everything that has to be on the page, and because of that, if you have anything to add, that would be a good time. Haven't you done it now, you have a pre-render complete. And that's the last point in the page life cycle when you can add something to your page, or when you can change something on your page. And I will show you right away why this is important to know about. After pre-render complete, ASP.NET will call your render method, and render method will send the HTML result to the client, and then it would be too late for you to change anything on the page. So let's see what kind of application do I have. For those of you that saw my talk a couple of days ago, you saw that I'm interested in cooking. So I have a website that has to do with recipes. So I have some recipes here on the side, and then I'm going to my page, you know, and the first thing you see is that main page. And then you have some random recipes that I might choose and see exactly how can you do it. And it shows here what kind of methods do I use for that. I take some timing, and it looks like 3 seconds. How many of you have a page that takes 3 seconds or more to load? Yeah, a lot of people. So that's not something uncommon. I will show you the code. It's actually pretty simple. I have a page load method, and on my page load, I'm starting to do some get details. I'm looking at the recipe ID that I'm sending, for instance, on my randomizer. I take this number, and then I look for the details. I look for the ingredients and for the instructions. Every method is quite simple. It's just, you know, an SQL command that I'm sending to the database. It's a stored procedure that I've created. And the stored procedure itself has a very interesting feature. And the feature is waiting for 1 second. So the thing I'm doing, instead of just returning the data from the database, I simulate some wait on the database. So the database will wait for 1 second before it returns the answer. That would be, you know, the counterpart of doing calculations or doing some sorting or bringing data from some more tables, doing joinings or whatever. 1 second, I think it's quite realistic to wait for a query on the database. But because I do a sequential call, what happens is that it will take 3 seconds. Every single call will take 1 second, and add it together, that will be 3 seconds. So let's take a look and see how can we test our application. In Visual Studio, we have something called tests that we can create, web tests. We have a load test, we have a web test. A web test actually just goes to a page and then expects some answer, and then it shows you, okay, if you do that, what do you get back? And I have some already done web tests, just to show you. I have one called fast load. What fast load does, it goes to my server. I have a separate server here that I'm using actually just to be able to do a better load testing on my application. So I'm not doing both the load and the response from the same machine. So I'm just going and read the default page, and then I'm taking the timing and see exactly how long it took for that to be done. So let's do a test here, and I can see that it took like 0.023 seconds to load this page. And normally what you want to do on your home or on your first page, on your default ASPX or whatever name you chose for that, you need that one to be very fast. You don't want someone to have the white screen of death and just waiting and waiting for like 10 seconds before your page shows up. So you want to have something very quick. And 0.023 is very quick for me, so I'm happy with that. I have another one that I did for my random recipe load. So I will do here the same. I will test this one, and then I say, if you go to random recipe, I am expecting actually that you do a redirect, and the redirect should return the page, and it shows me. The page itself took 3 seconds to load. I expected that everything is just fine. But what can I do with this information now? Well, together, I can create a load test. So let's do a load test on my application. I will call it load 1, whatever. The scenario is something like dummy test. And I will use a normal distribution. I will say that I will have 250 users. That's the maximum amount you can get by default in Visual Studio 2010. Fortunately, Microsoft actually released now a patch that you can apply to Visual Studio, and then you can have actually unlimited number of users when you test your application. But I will show you exactly what happens when I have 250 users. And think about it. I have a very popular site. I'm showing a lot of, hamburger recipes and pizza ordering recipes and stuff like that. So of course that people would be very happy to follow my site. So let's see. I say that I would have 250 users. I will do a mix of the test. I will say do whatever the number of tests you have and take an even distribution on that. And now I can have different web tests that I could add to my site, like that. And I say, you know what, just do both pages because I will do a mix. Someone will come to the main page. Someone maybe has put a shortcut or whatever in there, or they have a shortcut or a favorite on my random recipe page. So I will just do a 50-50 distribution. I can simulate different kind of networks. For instance, I am on a 3G, I am on a cable, I'm on local area network or whatever. I can even have my grandma testing the site with a 56K modem if I want to. And I'm specifying exactly what I expected for load here. I can use different kind of browsers. A standard we have Chrome, Firefox, Internet Explorer 5 if you like to. 9 it's not there yet, but I think they have some updates for that you could actually get Internet Explorer 9 and so on here, just to have a right browser mix. I'm not interested in that either. I can use some default counters, but because I do it on another machine, I'll just let it be right now. And I have some settings for my test. Normally, you need to have something like a warm-up. Every single time when you recreate or when you deploy an application, it will be recycled. So the first couple of requests might be slower, and I just don't want those to affect the numbers in my test. So what I'm doing, actually, I will say, you know what? Let's have a 1 minute, or you know what? Let's do a 30 seconds because we don't want to lose the time waiting for this. And then I will do a run duration for 1 minute. And I will get a sampling rate of 5 seconds. I can get a description. So the description will be some dummy test here. And I will press finish. When I'm done with it, I can just press here run test. And then it will start to run my test. The test itself, when it starts running, it shows me some of the key performance indicators. What I can see, actually, it's some system under test, controllers and agents, test response time, transaction response time. But what I'm interested in is page response time. How long does it take for my page to get back an answer? Yes, sir? Yes, this one is Visual Studio Ultimate, but if you have Test Edition, you get exactly the same features. So you don't need the Ultimate for that if you have the Test Edition. So the first thing we can see, actually, we are still on we are done with the warming up, but we are on the 11 seconds. So it's not 3 seconds anymore to load the recipe. The red one is the recipe, and the green one, actually, is my default page. So let's see what happens. I will get somehow normalized after a period of time. And then we will see that the mean value would be around 6 seconds for the default page from 0.023. That's a lot of increase or decrease in performance, and we will get around 8 to 9 seconds on the recipe page. Do you know why it's that? Sorry? Because 250 users, come on. I mean, 250 users is not that many people. I might have a popular website, but 250 is not that popular. Normally, you get 20 threads per core in your machine to be able to do all the requests, to work with all the requests that you have. And because I have 250 users calling simultaneously in my application, the maximum amount of threads that will be allocated for that would be 80. I can go into, because I have 4 cores on the machine, I can go actually into my ASP.NET and say, you know what, just allocate more threads. But the problem is still there. My threads are not doing anything else but just sitting and waiting for an answer from the database. And it's not a good way to use my resources. So we can look at the results here. We have like 11.4. It's the longest time, or the mean longest time for the page, the slowest pages. And I have here how many, I have the average values. It's 7.79 for the random recipe, and it's 3.65. So not only the random recipe page gets a decrease in performance, but the default page as well. Because all my threads might be busy waiting for something from the database, and all of a sudden I cannot deliver an answer. Because all my threads are busy. So as soon as one thread is becoming busy, then it will start maybe to deliver a response for the default ASPX, and so on. So, what is the solution? I can show you, I have some ready-made tests actually, so we don't have to wait for like 3 minutes every single time when I'm doing that. I have one called load recipe, and let me show you here managed results. I have the sync load, that's the synchronous one, which I did for 2 minutes. I get a nice graph, and it shows me that I have 10 seconds for the random recipe, or the average is 6.53, and the average for the default page is 2.40. It's still a lot of time compared to what I need to do. And the more users I'll have, the more problems I would have. And that's not because I do a lot of work, just because I do some I/O-bound work on my machine or on my server that will block my threads for a period of time. So what can we do? Well, we can look at the asynchronous pages and how does it work. You take a page, you can mark it actually with async equals true, and then you will say, you know what, you might be aware that something might be called asynchronously on this page. If you don't have any asynchronous call, it will not call any asynchronous methods in there. But if you do have, then we get something like, after pre-render, there is a special point in time called the asynchronous point. So whatever asynchronous operation you will have, it will be done between pre-render and pre-render complete. And pre-render complete will never be called as long as you have an asynchronous operation on the run. The only thing we need, though, is to say to ASP.NET, we do have some asynchronous operations that we are doing. You need to be aware of those. What's the advantage of using asynchronous? When you look at a synchronous method, what you get is you call the method, you wait for the result. I'm going to the database, I'm waiting for the result from the database. I will do one method at a time. Because I have 3 different database calls, I will wait for the first one, for the second one, for the third one. But it's very easy to program, it's very easy to understand. I have no other problem, nothing happens behind the curtains, nothing goes, at a non-deterministic point of time. Everything runs exactly when I say it should run. And if I have to wait, I have to wait. The advantage of using an asynchronous is the asynchronous method. It's you call the method, and then you get back the control. So you don't wait for the answer. The answer will come later on, and there are different ways of sending back this kind of information. You can either have a callback, or you can have, later on you can have some kind of waiting handle that you can wait on to make sure that everything is done. So you have different ways of doing that. The biggest advantage would be that you can run several methods at a time. So I have method 1, 2, and 3, like I have in my case, and then I will be able to run all 3 of them at the same time. I will get scalability. I don't need to wait for every of them to run. I just need to wait for all 3 of them to complete at the same time. The biggest challenge actually here is that they are harder to program. Or they were harder to program, because I will show you later on that actually with the new features in the next version of C#, they work pretty fine actually, and they look very, very, very fine there. So let's see how can we asynchronize our application. I don't know if asynchronizing is a word, but I think you know what I mean with that. So, sorry. Let's go back, and the first thing I'll need to do actually is to look at how can I do that. ASP.NET 2.0, as I said, introduced 2 ways of doing asynchronous pages. And ever since, there are only those 2 available. So there is nothing new, actually, since ASP.NET 2.0. So I can still call it a new feature in ASP.NET. How many of you have heard of add-on pre-render async complete method? So very few, exactly as expected. How many of you have heard of page tasks? Not only one person. Very interesting. Thank you, sir. So I will show you both way of doing that kind of stuff. So there is a method, as the name said, called add on pre-render complete async. That's part of the page class, so you'll have it on your page. Add on pre-render async complete, it's a method that has two parameters, one called begin handler, one called end handler. Both of those are actually delegates that follow this signature or signatures. Begin work that has a sender and an event args, and then it has an async callback and an object state. And then you have end work, which has an async result. Do you know what that looks like? Like the event handler. So if you think about it, we have a delegate class called event handler. Let me show it to you. So we have an event handler, EH equals null. Let's put it that way. As soon as you create a delegate, you get by default 3 methods, or several methods, but interesting for us are those 3. One is called invoke. Invoke, it's like you will call the method. It's exactly the same thing that you would call the delegate method you have there. The second one, that it's interesting, it's begin invoke. Let's look at begin invoke. Begin invoke has object sender, event args. Have you seen that before? It's exactly my begin work. The second one, or the third one, it's actually end invoke. And end invoke you need to call whenever you are done with the job you have to do. And I have an async result that I will take as a parameter. So let's try to do something with that, and I will do it, like any good chef, I will just do it from my toolbox, so I have a nice toolbox, and I will go into get details, and I will do something like that. I will comment out this, and I will drag and drop get details add on pre-render complete async. So what I've done here, I split my method calls in 2. The first one, it's begin execute reader. Begin execute reader, so if you remember, add on pre-render complete async expects a delegate, an event handler delegate. And what I'm sending here actually, it's a lambda expression that simulates the event handler delegate. So A, B, C, and D would be my object sender, event args would be the callback, and would be the async result. The callback and the object state, I will send it directly to begin execute reader, and then I will have to send a callback. So my callback would be actually the end execute. The reason I'm doing that way, it's not to confuse anyone, but for me it's much easier, for instance, to follow now the code. I would see that this one is pretty asynchronous, or it's asynchronous, and what happens when it's done, instead of going back and forth and looking for methods and trying to find out what happens there, and how do I call that, and why do I call that. So it's much easier, from my point of view at least, to put everything in one place. So this is the begin part, this is the end part. To get back the result, I will have to call end execute reader, and this is a method, both begin execute reader and end execute reader are methods available actually on the command class from ASP.NET 2.0 or for ADO.NET 2.0 and upwards. So you already have those methods. And then I get my async result that I can return back, and I have everything on place. Next thing I will need to do is to do the same thing with the get ingredients, like that. Let's take get ingredients. And it's the same thing there. I'm having an add-on pre-render complete async when I do a begin execute reader and then the execute reader for the other command, this command which is get ingredients for recipe. And the last one would be to do it for the get instructions. So, like that. So I got all 3 of them on place. I need to do 2 more things. The first one would be to go on my page, display recipe actually it is. I need to go on the display recipe page and make it asynchronous. So I have here an attribute called async equals true, like that. So I'm saying, you know what, this page would be asynchronous. If I'm not doing that, when I'm running my page, I will get actually an error telling me that you are trying to do some asynchronous stuff, so please go back and add your async through to your page, because otherwise it will not work. That's the first thing. The second thing that I will need to do is to change my config, my connection string. What I need to do in my connection string is actually to change, to add an asynchronous processing attribute and mark it true. I did another thing. I just make the pool size of my database to 1,000. Why? Because I might have, or actually 750 would have been just fine, but I might have 250 users at the same time running 3 concurrent database calls at the same time, opening 3 concurrent connections of the database at the same time. And because of that, I might actually get some timeouts on my connection, and instead of having an increase on performance, I will get a decrease because I won't have enough resources at the database. So my connection pool has a standard max value of 100, so I need to make it bigger in order for me to accommodate that. Most of my calls are quite small. They're like 1 second, so I'm calling, closing, but I need to make sure that I'm closing the database connection, so I do have back my resources. So let's test and see. Let's make some changes here as well. In my display recipe, I need to change and say that this is the async on pre-render complete stuff, so at least I know that I'm having the right version on the server. Let's try to debug it just to see how it looks the first page, if it's okay or not. I go to the random recipe. It still takes 3 seconds, and I'll explain you in a second why. I do a refresh, it takes 3 seconds and some additional time to render that. Okay, let us deploy this. Publish successful, and then we go back and take from the solution, we take the load recipe, load test, or actually let us take the smaller one just to see how it will behave now. So it will go on the server, it will try to reach all those pages. If I go to the page here on the server, if I say I feel lucky, I should get, instead of sync test, I should get add-on pre-render async, complete async. So that means that I got a new version on the server. So I'm running with the correct one. So we get the warm up, and then we will see that we will get a drop on this curve. And what we will end up with is that the default page will now start to take around 0 seconds, or the old 0.023 seconds to load, which is actually what I wanted from my application. The second one, the original page, will still take 3 seconds. But because I do it asynchronously, what happens is actually that I'm freeing up the worker thread. And I'm saying, you know what, let's do the work on some other thread, whatever thread you have on the thread pool to give me, so you can actually take care of new requests coming, because the threads that I'm keeping busy here are not doing anything. They're just waiting for the stuff to be done. So you can see now that the result is becoming to be a nice looking line. We got the warm up, and then we got now very nice looking curve for our results. Isn't that something? But now back to my original question: why does it take 3 seconds? Do you know why? Add-on pre-rendered async complete. Add-on pre-rendered async complete actually will just run one after the other, will not run all 3 at the same time. So in order for me to do those things, to run all 3 at the same time, I will need to use page tasks. So a page task will help me actually with that. So you can see that the graph is looking very nice, and I have those kind of results. Let's look at this other longer test and see how those are looking like. I have add-on pre-render async complete. So you can see I got like 3 seconds and something, and right above 0 seconds for my default page ASPX. So it's a very good improvement anyway for my application. So by using page async task, Microsoft did it actually quite simple. It's almost the same as you have it with add-on pre-render complete. But instead of that, we need to use the page. The page class has a method called register async task. And register async task takes a page async task parameter, which I will provide new page async task. The constructor of page async task has two overloads. The first one takes a begin event handler, the same one like we had on the add-on pre-render complete. The second one is an end event handler. It adds a third one called the timeout handler that looks exactly like end event handler, meaning that I could get an indication that something went wrong with my data, with my call, or it took way too long, so I need to handle that as a timeout, and I might have something else to show. I will say, okay, you know what, come back later. There are way too many people that don't know how to fix a hamburger, so you would have to come back within 5 minutes or whatever. So I can send this information, and then I have object state. If I want to send some extra information, I would send it via the object state. There is another one, overload, which I missed actually the first time I was working with that, and I never could figure out why my application still runs everything sequentially. Because what I did, I put everything like that, and the last parameter I put true, being 100% sure that this is my execute in parallel. So what they add one overload that takes a Boolean parameter called execute in parallel. When you do an execute in parallel, we'll just start all the tasks at the same time. The tasks will all be started in your on pre-render method, and then you will wait for the answer on pre-render complete. You could actually start the execution of your tasks earlier if you need to. So let's look at the page async task here, and then let's add some more parameters. We will add a parameter which is the end event handler. Null. We will send no state, and we need to say true here, meaning that we want to run this in parallel. And let's close the parenthesis of the constructor. So very easy to change, very easy to add new functionality. I have the same for those other two. Let's see, like that. Get ingredients, yes. Was the get ingredients? That's good. And then we have get instructions. Great. Like that. So I'm doing exactly the same thing for the next two of them. Let's compile. I forgot somewhere a parenthesis. Where? Get instructions. I removed something here. Oh, this one is too much, I think. Yeah. Yeah. That was it. So let's change as well this to text, so we are sure that we have the right version on the server. Oh. I learned it the hard way, you know that you have put it there, but it's not there, so I need to make sure that I do that. So I will do a deployment here. I'm using web deploy actually to do that, and it's very, very convenient. So let's do a display recipe number 5 and just see what we got here. Look, 1 second. I have 3 calls on the database. All 3 of them are independent on each other, so I could have parallelized those with no problem, and that's what I did, and it works. There is another advantage. You won't need to mark your page as an asynchronous page when you do that. It's okay to be there because there is an indication for your designer that you have an asynchronous page and something might happen behind the curtains in an asynchronous manner, but there is no need for you to have it anymore. The async equals true, it's only needed for add-on pre-render async complete method. It's so long that you will never forget it. So let's try and see how does it look when we do the tests for that. Go back in the Solution Explorer, do a load recipe, and then let's try to see the results here. Open Manage Results. We have the page async task, and it looks like that. It's like the average is 1.5 seconds for the recipe. The load is, for the main page, it's 0.33 seconds. I have some spikes in here. Do you know why? Sorry? Not really. The problem I have here actually is when you run the test for too long, you'll get something like a threshold violation. I can actually fire the thread while I'm speaking. No, not you. Come on. I need to fire the test just to show you what happens. Nope. Debug. Stop debugging. And let's do the test here. Like that. More than one local run. Now it will run. So what happens actually is I get thresholds violation. What kind of thresholds? My processor, it's working 95, 100% for more than a couple of seconds, and I get a bottleneck in my processor. But that's okay. I mean, I can do as much work as possible, I will get the bottleneck on the processor, and that means that I will need to have another processor, or I might need to scale out my application. But because I don't have any more the problem that I had before. So we will let that run, and we'll see exactly what happens after that. I said that I will show you as well how you can do that with an ASP.NET MVC application. How many of you have looked at MVC? Okay, so that's great. MVC2 introduced the concept of asynchronous controllers. So when you do normal MVC application, you have a controller and you have different actions in the controller. So we still have 2 minutes there. Let me just go into the MVC code and show it a bit to you and see exactly what are we dealing with. I have a recipe controller that shows all the stuff, and I have a method called here display recipe. Instead of using ADO.NET, I'm using Entity Framework, more or less the same thing. I'm just reading the data from there, and then I'm getting some measurements and some indications about how fast the application went. So I have a view model. I have the view model because I'm taking data from different parts. I want to combine it in one view model, and then I show it on the page. So let's see what my load recipe does. So as you can see, we get that, and we get a lot of threshold violations here. And if you look at that, it says the processor reached 99%, 98, 100. That's the nightmare of the IT pro, of your IT admin. He will just go crazy. No, 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 you're killing my machine. No, I'm not. I'm working it. So, yeah. That's what you get. But you will get some threshold violations. You get no errors, actually. You just get some indications that, your server is busy. So let's stop that. So you got the point. You see what happens, and you can see exactly what the result might look like. And you get those spikes because of you don't have the processor resource available. So now let's go back here to the recipe controller, and let's see how does it look like. So I'm trying to run my application, and when I run that, I will see the result. Almost the same. I haven't implemented everything. I just implemented what I really need, meaning this random recipe. And the random recipe works the same. You go to an action called display random recipe, which goes to display recipe with a random number. So you get this, and the result is almost the same. But it takes 3 seconds. So what we need to do now is to make it asynchronous. And we have several options on doing that. But the first thing you need to do, actually, is to make your controller an async controller. By making a controller an async controller, you will get an extra property called async manager. In the async manager, you have some methods that you might use in your application. Next thing you will need to do is to change the method. Display recipe would become a display recipe async. That's a requirement. So you split your method in 2 methods. One called display recipe, or the original name plus async. So this method would return void. And the second one would be public. action result, and it's called the same as this one, display recipe completed. Or complete. We'll see right away. And it can take some parameters. What do I want to send as a parameter in this one? I will send actually this display recipe view model. So I will put it as a parameter in that method, and then I will need to send it to the method. Let's do that, and let's just move this one. So that's the first thing we need to do. The second thing we need to do, we need to explain to the system what happens. When are we done with the work? So I will go here, and I will say async manager dot outstanding operations. How many asynchronous operations am I starting? Outstanding operations, I have an increment with 3. So that's what I'm doing. I'm doing 3 concurrent operations here. I will need to do something more here. Namely, I need to make sure that my context, my entity framework context actually, it's duplicated on every single call. So I will do something like that, and like that. And I will show you what I'm doing with those now. I take this and I will do a parallel, for instance, .invoke. As simple as that. And I'm sending 3 different methods that I want to be run at the same time. So the first one would be the first call, and like that. The second one would be something similar. And let me see what I'm doing wrong here. And like that. Closing this parenthesis. And closing this and this, like that. Looks nice. And after I read that, I will say async manager dot the outstanding operations dot decrement. So I'm done with the asynchronous operation. You can just move on. Or when all 3 of them are called, or when this is called 3 times, then we will go back and just return the operation. One last thing I will need to do here is to send a parameter. So what I will do, I will say async manager dot parameters, and the name of my parameter is actually model, so I will use exactly this name. It's nothing more than a dictionary, and it uses the regular binding that you have in MVC applications. So the name would be model equals model, the model that I'm just creating over there. Compile the application, and the result would be that now I have some asynchronous operations. Finger crossed, let's see. Doing that a couple of times. 2, good. 1. So that's the result. I haven't done any load testing on that. If we would have done, the result would be exactly the same like before. So I'm just doing this parallelizing. So what you will need to be aware of is that you will need to have the outstanding operations so that you'll tell exactly how many asynchronous operations you have. If you have only 1, it's still enough because you will free the thread. You will free the worker thread so you don't get the resources, or you won't keep the resources busy if you want to do it. But because I have 3 of them, I do everything in 3 different steps. I really need to do the context here to have 1 context per call, because the way entity framework works is that after every call I'm doing, it will close the connection. So the next one will just tell me, connection already closed, you have an invalid operation. So that's what I failed a couple of times before I found out that this is the way to do it. So yeah, and then you need to make sure that when you are done with your operation, you will call a decrement on that. So when you reach 0, then ASP.NET will call automatically your display recipe completed. Yes, sir? Can you give him a microphone? I don't really hear the question. Or
Hey.
Yes.
Should we include the decrement call inside of a finally block in case there's an exception thrown there?
Yes.
Okay.
You need. Otherwise, if you don't do that, you will never get called the completed method. So you'll need to do that. Yes, good question. So if you know that some exceptions might occur, either you use some using or you use try finally just to make sure that the decrement is called. Okay. So that actually concludes the part of regular way of doing it. How many of you have seen the PDC keynote with the async and the wait? How many of you looked at async and the wait keywords? Okay. So Microsoft is actually coming with something very, very interesting. We got two new keywords in C#, one called async, another one called await. Behind the curtains, they are using actually task and task of T, so it's still based on TPL, but they are the preferred way of doing I/O-bound operations, meaning database calls or web services call or whatever you want to do. The biggest advantage is that it will look like your regular synchronous call. Whatever you need to do, you need to make sure that you add a call to your method, and you will add the async keyword, for instance, at the method, that you mark the method as an asynchronous method, and you will add an await for that, so you make sure that everything works as expected. And more than that, it's not actually to it. The biggest news with that is that Microsoft supports the CTP, which sounds pretty peculiar. I mean, CTP stands for Community Technology Preview, but if you choose to install it on your production environment, Microsoft supports it fully. They even want you to give them feedback if you have, and they are now at the second iteration. If you have installed the first one, you will have big problems. I know that I have to reinstall this machine, for instance, in order for me to get rid of that, because you need to uninstall it before you apply the Service Pack 1, and then I applied the Service Pack 1 without uninstalling it, and then a lot of big problems. The newest version, it works, it's compatible with MVC3 even, so you can use it in any way you would prefer in your application. So let me show you how do I modernize my application, how do I bring it to the VNext of C#. So I will go to the display recipe ASPX, and what I need to do actually is just take my original methods, let's do like that. And the connection close might be there, remove everything else. Let's do it with the next one. Like that, and comment away page. And then, same here. Like that. So that's the first step. The second step is that I need to mark the methods. Yes, sir. Oh, yeah, thank you. And that would actually, hit me harder later, because I won't have any databases, and I would wonder why my application goes so slow and slow and slow, because I'll get a timeout for my connections. So thank you. Okay, so I will need to prepare my methods for that. So the first thing I will need to do is to mark the method as an asynchronous method. To be able to do that, actually, I will need to add a new reference, Solution Explorer. I will write it right away. I will get an error, but that's okay. And then, when I need to wait for that, I can have a method that returns a task. Same here. I can do, instead of void, Microsoft recommends that you return a task. That's especially when you have, for instance, an asynchronous method. You can return three things from an asynchronous method. One thing, it's a task. The other one, it's a task of T. And the third one, it's a void. So if you don't want to wait on the asynchronous method, you don't need to put any task. If you had a return of int, for instance, then the new return of the value would be task of int. Because I had a void return, the new result would be just a task that I'm returning. So that's the first thing. The second thing. The third one would be to mark the method as an asynchronous. It's not a requirement, but it's a recommendation. By having async on the name, I will get an indication that this method does something a bit different than the normal way of doing the stuff. So I get to get instructions async. And then, what I need to do, I need to have an awaitable method. Awaitable method, it's a method that does actually return a task in some case. So for instance, if I want to do an execute reader, The way to do it, I will go here and I will show you how I did it. I will do an execute reader async, and for that I will use the task completion source. The task completion source, it's a special class that will simulate the task, will run your asynchronous operation, and you would actually mark either the result or you would return an exception. So I'm saying, begin execute reader, and the result would be actually either the try set result for the end execute reader, or an exception if I get an exception while I'm doing the end execute reader. And the return value from that would be the task itself. And the nice part actually is that Microsoft was thinking about that, and all those most used methods that you have in your applications are already implemented as an asynchronous method, extension methods for your application. So let me go back to this execute reader. Now I can go and add a reference to the asynchronous CTP. Add reference. I have recent, it's async CTP library. By adding this, everything now it's turning green. It's just a warning nowadays telling me, you know what, you have an async method, but you have no await operation. So it doesn't make any sense for me. But if I need, now because I know that, I can go in and say, you know what, this execute reader is implemented as an asynchronous method. So I have an async execute reader, and I can say await. Like that. That was about it. So from synchronous method to asynchronous method, you have, let's say, 5 steps. Async, task, if you want to change from void, and then you should add the suffix async just to mark it as an async, or to show to the caller that this is an asynchronous method. And then you have to call the asynchronous version of the method. If you don't have one, you can implement it on your own. There are several versions. For instance, there is a task.run now that you can do, and the task.run will just run your synchronous method, but will return a task that you can use in an IO-bound operation. Let's do that, and let's take all the async methods from here. See, I think I have implemented all of them asynchronously. Get instructions async, I have already like that. So I can comment out one of them. Like this. Through KC. So I have get instructions async, get ingredients async, and get details async. Like that. Compile. Get instructions. Oh yeah, I just removed the method. So now I can go in here and call get details async, get ingredients async, get instructions async. And to mark that I need to wait for the result, I need to do something like that, await on that, await on the next one, await on the third one. Now I get another error telling me that you call await in a method that does not use async. So I need to go to the page method here, page load, and mark this one as an async method. So like that. Compile again, and now I'm done. What would happen if I run now? What would be the response time? 1 or 3 seconds, one of those. 3, yeah, because even though there are async results, whatever they will do, they will free my current thread, but they will not do the next step until I'm not getting back the result from the await. So it takes 3.18 seconds. I might change it a bit, and I will say, that I want to use an async and await and stuff like that. Let me do it like this and say async await. If we look at the result, load recipe, for instance, let me take this load recipe load test, and let's take async await, open and manage results. We have async await. We will see that we get the 3 seconds, 0.16 seconds. That's the longest time that we got. So it's a very good result that we get. Average test time, it's 0.42. So it's even better actually than using the old way of page task and register page async and that on async pre-render complete and so on and so on. Why it's better? Because the way they implemented that, they are not using threads, they are using something called IO completion ports. And when I heard, the first time someone telling, no, but we don't use any threads on that. How can that be? Was the first question I asked. I said, no, that's the biggest mistake that someone can make on stage. But actually looking inside how they did it, they are not using any threads for that. They are not using tasks. They are using something that is specifically made for, at the operating system level, that is specifically made for I/O data. And if we look at the graphs, we can see how nice they are going. But then how can we solve the problem? How can we make it, to do all those three in parallel? Well, the result is the way of doing it is very simple. Let's go here, Solution Explorer. Where is my display recipe? Here. I'll need to do something different. I will say like that, var t1 equals var t2 equals. So I'm not waiting for the result. I'm just firing up all those three and say, you know what? You start with those kind of stuff. And now I can do something like await T1, await T2 and T3. T2, T3. Because I'm now firing all those three without waiting for them to be ready. Even they're still asynchronous. They are still done, outside the context of my current thread, but they are done in parallel. Let's compile that. Let's change this one to correct implementation, or let's say parallel implementation, because both of them are correct. You might want actually to have something done in sequence, so it's not like it's wrong the first way of doing it, but if you don't have any dependencies on your stuff, you can do it actually like that. So compile it. Let's just see what happens now. Random recipe. Come on. 1.02. Much better. Let's see the test. How does it look like? We have a load recipe test. We can look directly at the results. If you want, we can wait for 3 minutes. I have no problem with that, but I think it's much easier if we just look at the results. I was stayed up all night just to record all those stuff so we can have it and we can have a quality time instead. So 1.48 and 0.32 seconds for my pages. And if we look at the graphs, we will see exactly that we have the spikes like before because we are actually working the machine. We are pumping it. You can do exactly the same thing actually with an MVC. I don't think I will show it because it's not so much to show. I will just mark this one as an async, and then I will do, instead of parallel invoke, I'll do something like let's do like that. Task T1 equals task X dot run. Task X are actually methods that are available from the are available in the new async CTP, and there are extensions that will be added to the task class in the next version of C#, but the problem is that Microsoft cannot go in and change existing libraries just to add methods. In the next version it will be possible, but they cannot change it right now, so that's why they have two methods. And I can do like that, run it, or I could even actually do it in here. I can run it here. I will say something like await, on the task that does that. So there are different ways of doing it, but both of them are working. The only thing that I'll need to do is to mark the method as an async, add a reference to async CTP, and then everything will be just fine. Behind the curtains, parallel invoke, actually it's using three tasks to run those three in parallel. Otherwise, it wouldn't run in parallel. Okay? So, every good thing's come to an end. So is this talk. We looked at some of the page life cycle. We looked at some of the features that you have, how you can load test your application just in order to make sure that you get the right result. We talked about asynchronous pages in ASP.NET up to 4.0. We looked at asynchronous actions in MVC 2 and 3. We talked about async support in the next version of C# and how can you use it in your application. Thank you. And if you have any questions, please ask them at the microphone. And yes, complete evaluation, please. You might win a Kinect. Okay, questions? Can you get to the microphone, please? Yes. Can we get the microphone over there, please? Yeah, now.
Test. Is this going to be available in VB.NET?
It is already available in VB.NET. The only difference is that it's async and the wait are with capital A. Sorry.
No, okay.
So
Quick question on the critical threshold that you incur there after a minute. Is that imposed by the load testing that's taking place?
Yes.
Or,
yes.
I mean, is that an exception that's being thrown inside of the test environment that's causing a CPU spike?
No, no. The CPU spike is actually because I do a lot of work. Think about that. I have both the database here and my web application, so everything is on one machine. So I'm just putting all the load in this machine. And what they are doing, they are looking at what you can do actually in your test. You can choose counters. I told at the beginning that I'm not interested in any counters, but by default you get the processor counter, you know. And if you go above, I think it's 85, it's the baseline that they will use for more than 5 seconds, then it will say, okay, we now get a threshold violation.
It's the OS doing it.
It's the regular performance counters that you have in Windows.
Okay.
Yeah.
Thanks. Appreciate it.
Yeah, you're welcome.
Can we? Hello?
Yes.
Hi. Is this working?
It looks like.
Can we target 3.5 with the new C# language?
Almost. You have the
Almost.
reactive extensions actually that add a lot of tasks. They backported a lot of task implementation, TPL stuff into the .NET Framework 3.5. Unfortunately, async and the wait will not be available for that. So you would have to go to 5045 or whatever the number would be, or something. Yeah.
Thanks.
You're welcome, sir.
It's available in Visual Basic?
Yes, yes. So async and the wait are actually, they are working to make it available in both of them. When you download now, you have samples both in C# and in VB.NET, and it's available.
Thanks.
You're welcome, sir.
Yeah, so it's really cool, but it's scary at the same time. So.
But it happens all the time, It happened to a friend of a friend, so.
Yeah, no, but like, do you recommend it using in like high availability systems where you have lots of traffic, like high?
Especially there, yes.
So you don't think it's going to kill SQL Server, for example, which is usually the bottleneck?
You need to do, the SQL Server will be on a separate machine.
Correct. Yeah, it's on a separate machine, but but instead of like doing it in parallel and then like using your like connection pools in a smart way.
Yeah.
Now you kind of like every request will use multiple connections from the connection pool at the same time.
That's true, and that might not be the best pedagogical example I could have given, but what I want to illustrate is that you have 3 different calls at the same time. Right. Normally, it's quite seldom that you have 3 independent calls. You would have like 3 calls, or 3 calls that are somehow dependent on each other. So you need to wait on the first one to go on to the second one. Yeah. And because of that, you'll just reuse your connection. So you don't have to
Actually, if the database is the bottleneck, we need to use a distributed caching and then on the other techniques to take a lot of the database.
How do you know that it's your database the bottleneck?
Huh?
How do you know that it's your database the bottleneck?
Because it is. Yeah, we know, like through different encounters and stuff like that. So we know it's a bottleneck. That's why.
Okay, but maybe that you can do something there and make it better.
Yeah. But you think, but your impression is like, it's ready to use.
Yes. So
it's not scary.
Not for
because
me.
on early versions, for example, of Entity Framework, like even people from Microsoft were saying, it's not serious yet. So you can play with it, but it's not serious yet.
Did I look scared on stage?
Huh?
Did I look scary on stage?
No, I'm saying it looks
it's
really
not
cool.
scary.
It looks really cool, but scary at the same time.
Yeah,
so.
it is. But I think it's, the scary is the add-on pre-render async complete maybe, because it's too old. If you look at the sync and the way I think it's so, I might sound a bit geek, but it's so beautifully implemented that I really love it. Sorry,
Okay, cool.
geek warning. So
Yeah, that's right. Thanks.
yeah, you're welcome, sir. Yes.
Is there a particular benefit to having like the async controller rather than like say having a regular controller method in there that just invokes, just carries out its tasks using like the TPL calls?
So if you have a CPU bound, go with a TPL. If you have an I/O bound, go with a sync controller because you mark to the ASP.NET that this has to do some other stuff, and I want it actually to be done asynchronously. So go with a sync controller for all I/O bound stuff you have.
When
I/O bound means that you read a web server service, you access other resources outside of your machine or of your process even. Not doing calculations. If you just do calculations, if you count to 10 million as quick as you can, then yeah, it's a CPU bound, and you don't need to do any asynchronous task on that.
I see. Okay. Thanks.
You're welcome, sir. Yes.
Easiest question of the day. Can you go back to the slide where your contact information?
Oh yeah. Sorry. I was so quick on this one called don't forget to evaluate. So I missed it. Yeah. Yes.
So I have a question. You said that they're not using threads anymore for the. I think you mentioned that.
Yes. That's right.
And we need to patch the server.
You don't need to do anything. I mean, if you install the async CTP DLL, they will do all the patching, all the stuff. There is already, actually, Windows since version 3.0 had something called I/O completion ports. So an I/O completion port, it's not a thread. It's just a way for you to start asynchronous I/O. There is already available on the Windows operating system. The only thing they did now, they started to use it more, exactly because you have I/O stuff that you need to take care of.
All right, thanks.
You're welcome. Yes, please.
Does this work on Azure?
Yes, it does.
Okay, that platform. So do they have this installed in?
I think you'll have to do it on your own. You'll have to put it on your bin folder, but yeah.
Okay.
It's not that hard.
So it's just a bunch of references and
Yes,
that's it. Okay.
Exactly. Yeah.
How does that? Oops! Wow, that's louder than I expected.
Okay.
How does this affect like session management and that kind of thing?
What do you mean?
Well, you just mentioned that it's not running on a separate thread. So are you still, can you share the same session objects?
Yeah, you still get the same context object. That's what you will be actually interested in. So you'll still get the same context object. So what you are doing actually, you are freeing your current thread saying, you know what, if you get some other bunch of stuff you want to do, just do it, but then come back to me, I mean, I free you for like next couple of seconds, but come back to me because I would really need to continue to do some work with you. So that's what it does, and that's the beauty of it. What I haven't shown actually here, and I tried to avoid, is that async pre-render, add-on pre-render complete async, whatever method. It's easier when you have the IntelliSense in front of you. So when you use that method, you don't get the context object. So add-on pre-render complete will not have access to the context object. So if you need it, you'll need to add it as an object state or whatever else you want to include in your asynchronous call. If you use page async task, actually it will have access to the context object again. That's something I haven't mentioned because I really recommend using page async task, and I don't think it's worth mentioning.
Right. Okay. Thank you.
You're welcome. Okay. Okay, please.
On that same thing. So if you use page async, we still have access to, say, HTTP context.
Yes.
But if we use the other way, we don't have access to it unless we pass it in the state.
Exactly. Okay. So please evaluate, and thank you for being such a great